Hi, welcome to the Calculus 1 lecture series. We are in the unit number 4, integrals. We almost finished this unit, and now we are in the lecture number 28. In this lecture, we're going to talk about indefinite integrals and net change theory. In fact, this is a very easy lectures here. Okay, let's go ahead and go to our lecture notes here. Okay, so the first thing is here, let's take a look. How do we define the indefinite integrals here? So the indefinite integrals, we defined the definite integrals in the previous sections, right? Definite integrals will be the this is AB f of x dx, right? So you have boundaries here, and then really this one's here. If f of x is a non-negative function, then this is really kind of give you the area bounded by these functions and the x-axis and these two bound, right? So the indefinite integrals here, let's try to write down the definition. The indefinite integral of f with respect to x, and is written. So let's, how do we write it? The indefinite integral, we just do f of x dx here. And what is here? And this is the what? This is the antiderivative of the what? This is the antiderivative of the f. So as you can compare, right? So for the definite integral, you have the boundary, and for the indefinite integral, you don't have a boundary, and basically it's just try to find the antiderivative. And we talk about the antiderivative in the previous units, the last section of the previous units. That's how do we, we defined it. And so now in here, so like in here, let's take a look. So if for this one here, they say evaluate x to the fourth, right? So by the antiderivative, so what is the answer here? Will be the x to the fifth over 5, right? And don't forget the plus c here. And now the second part here, this is also another indefinite integral. So you find the antiderivative. So it's 12. So what is x squared? Is 2 plus 1. What is that? It's 3 and 3, and then plus c. So what is this one's here? So this is 4x3 plus c. Okay, so the same way is here. Now we know what is the x to the, so like 6x really is x to the first powers, right? So the antiderivative will just be the 6 and x to the square, and the 1 plus 1 is 2, then plus 2 times this is x to the 4th and to the 4. Hey, don't forget plus c. So this will give you 3x squared plus 3x fourth plus c here, right? So now the next one's here, and here's a constant. You can move the constants out. So the cosine, what is the derivative? The antiderivative for the cosine is sine x. Then the minus, what is the derivative will give you second? What is the antiderivative for that? It will be the tangent x, that's right, and the plus c here. Okay, now let's take a look at this one's here. So this is the x. So what? So remember the x. This is x to the first power. So this is x to the square to the 2, and the minus. What is the derivative for the sine? Hey, what is the derivative? So in here is very convenient to have negative sign. So what is the derivative for the become negative sign? Is what is cosine x, that's right, and the plus c. So let's just basically find the antiderivative, and we are quite familiar with that. And now here, this is the antiderivative we like. This is the constants we put in the front. Then ex just by itself is ex and the plus c. That's why I say this section is super easy sections here. And then now the next one's here. Let's see the truth or false. So for the indefinite integral, you have a times a constant. Well, you'll be able to move the constants out, right? So this is true. And then this one's here, this is f of x, you square inside. Will that be equal to you take the integration and square? No, right? So this is not truth here. So that's why the same thing here, if you have the product f of x times gx, and will you be able to separate it to the product of two things? No, so it's a false. That's just the same as the product rule for the derivatives, right? All right, so now this one's here. So the d dx, f of x dx is equal to the f of x. This is true or false? How? We say this is true. The reason why this is true, because by the fundamental theory of calculus, we know, so what do we know here? We know the integration and the derivative, they are kind of like the inverse function, they cancel each other out, right? Okay, so now let's take a look at this one's here. The phi, the dx is equal to phi plus c. This is true? No, this is false. The reason why this is false, this is phi times 1, right? The dx. So what is the 1 here? 1 is x to the what? 0x, right? So it's dx. So this will be phi, then the 0 plus 1 is 1, the x equal to 1. So it should be 5x plus 6 here. All right. Okay, so now let's go to the next ones here. So what do we talk about is the net change series, okay? So the net change series here, let's say here, the net change series says, okay, let for function that for function are not non-negative, then we say the definite, integrals represent a net area. Okay, so so from the previous lecture, we talked about the definite integrals, right? So we said the definite integral, if f of x is all be, like if this is my f of x here, right? So it's above the x-axis if it's positive, it's non-negative here, okay? So then we said when you do the integrations, right? So we are really is take a look at what? So we are really is to take a look at the areas, right? So this is AB f of x dx. So if this area is A, then we say the definite integral is A. Okay, so for this ones here, let's say here the function are not non-negative, right? So be careful, the function is not non-negative. So what's that mean? That means your function could go to the negatives here, okay? So that means in here, so if this is your function, so what is your function looks like? Let's try to do here. Fine, okay, so this is my functions here, and this is my A, and this is my B's here, right? So if this is your, okay, if this is my, so like if you put the boundaries here, if this is your f of x here, so what I mean if I say, hey, I'm going to take the integration of AB of f of x dx. So basically, so we know like for here, you can find the areas, right? So this area and this area is below and then this area is above, right? So if I put we know the area is always positive, right? So if I say this is area 1, this is area 2, this is area 3, this is area 4, right? So when you do the definite integral from a to b, see here, correct? Right, so here is your a to b here. So what do you try to do here? You find what? You find the net area of this function. So basically that means what is the area here will be the negative a1 because it's below the x-axis plus whatever the area, the a2 minus a3 plus a4 here. All right, so that is, now we kind of extended the definite integrals, not only for the functions above the x-axis. So they can go up and down the x-axis. Then when you try to do the definite integrals, you just treat the area below the x-axis, it's negative. So, all right. So now let's take a look at these problems here. Like number 3, they said evaluate x cubed 2 to the 3. What does this number represent? Of course, you can do like what we did before, right? So you said, okay, so this one's here. I can do like this. I just take by using the fundamental theory of calculus, I just take the integration. So what is the integration? It's 4. This is x to the 4th, right? Then you put the 2 and the negative 2. So what happens here? So you will have 1/4. So 2 to the 4th is 16 minus negative 2 to the 4th, right? So this is 1/4. This is 16 minus 16 is 0. All right. But then what this number means here. So if you take a look at x3 here. So let's take a look at our functions, right? Okay, so this is 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. All right. Okay, so now if you said, okay, x3, right? So it will be some function like this, right? So this will be what? This will be your f of x functions. And then now you want to integrate from -2, right? So -2 is here, right? So this is -2 to +2 here, right? So basically you are try to do the, so like we talk about this is a definite integral, is try to find the areas, right? So this area and what? And this area, correct? And because of x3 is an odd function, so I know the green area going to equal to the yellow area, but then by the net value theory, so what happens here? So when they add it up, you just need to use green, add the negative yellow, right? So that's why it's the 0, that means here, right? So I know if I have odd functions here, then if your integrations here is symmetric, then you'll be able to see that is what? That is 0s here. All right. So that, because of we know the net value theory, of course, your boundary has to be symmetric. So like for these ones here, like x cubed dx, right? So if you have a -1 to 1, this will be equal to 0. Also, you don't even need to do the integration, you can just like see that because about the net value series. So for the other functions, right? So that's why for the other function, when you integrate symmetrically, then it will be 0s here. Okay, so let's take a look at the last ones here. Let's say if Rx is the revenue obtained by selling the X units, then the marginal revenue R prime, what is the R prime X dx? Okay, so now this one's here, right? So this one's basically, we talk about this is the total change, right? So this is the total change. It's kind of like we talk about the net value series also. This is a total change in revenue, right? When the number unit is sold. Okay, so the increase from X1 to X2, right? So now because, so like in here, the R prime X, right? So by the fundamental theory of a calculus, what you have to do, so this is Rx, right? Because you find the antiderivative, then you put the upper bound and the lower bounds, right? So that what is the Rx2 minus Rx1 here. So that is what we said. This is the total change in revenue because this is a revenue function. So how much is the change from the X increase from X1 to X2 here? Okay, that's it. So like I said, this section is a very, very easy sections, right? So the indefinite integral is just use our, the antiderivative concept. Then the net change theorem basically just extended what our definite integrations from all above zero to sometimes you have a the below zero, above zero. And then when you do the integration, what they try to do is really to try to find the net areas bounded by the curve and the x-axis. All right, okay, that's it. And so our next video, we're going to talk about one of the very, very important calculus rule we call is the substitutions here. All right, okay, so that's it. And nice to talk to you and have a good day. Okay, bye-bye.